Okay, let me go ahead and share my screen.
Joel, just so everybody's aware of it, guys, if someone has a question, just go up to that little emoji up on the top there with the hand and either raise your hand or take yourself off mute if you're on mute and just ask the question.
Absolutely. Thank you, Randy, for that. Yeah, we want to make sure everybody doesn't walk away from this training or goes away from this training today with unanswered questions. So this is your time. We've blocked out plenty of time for the training today. And so let's go ahead and plan on asking those good questions if you've got good questions. So everyone should be able to see our home screen. It should say HMH7 heat pump overview. And Randy, we should have that home screen right now. We'll go ahead and get started once you confirm that for me.
Looks good.
Okay, real good. Let me do one other thing real quick. I'm going to go ahead and shut my camera off because normally what happens, let me back up just a second. Because normally what happens is the streaming is actually better if I don't have my camera on. So let's go ahead and do that at this time, and we'll get back to sharing that screen. Okay. All right, Randy, so you should be able to see that home screen clearly at this time. Is that correct?
I got it.
All righty. Well, team, let's go ahead and get going then. So the first thing we want to remind everybody, even though the units kind of look like a mini split, these units are not mini splits. Now they have some similar technology as far as a modulating compressor outside and all that, but they're designed to be hooked up just like a regular heat pump, which means you're going to have a suction line and a liquid line. You're going to insulate the suction line like you normally would. On the indoor coil, it's going to be just a standard expansion valve, an air handler or coil inside. And we'll talk a little bit more about this, but you're going to select just two speeds. You're going to have a low speed, which is going to be 60% of your full cooling airflow, and then 100% airflow. So unlike a mini split that's going to have, modulating outside, modulating inside and all that, this is not a mini split product. So I just wanted to stress that to everybody. It kind of looks like a mini split. As a matter of fact, I want you to please remember that the unit service fittings are 5/16, kind of like a mini split. And you're going to need one of these adapters to go from 5/16 flare down to a 1/4 inch flare for your service hoses. So please remember that little adapter that we're showing you right there. Those are readily available from Robinair and Yellow Jacket and JB Industries. They all have something similar. So 5/16 flare down to 1/4 inch flare for your service hoses. And that is similar to a mini split, but again, one more time, these are not mini splits, so we're going to treat them just like a regular plain Jane heat pump. You'll notice on the right-hand side of the screen, that's the 2 and 3 ton model with a single fan. And then the 4 and 5 ton model feature 2 fans, so you can tell them right away, what you're looking at specifically. Another good question we get asked quite a bit concerning the product is some of the operating temperatures. So you should see a little text field there that shows as far as the outdoor coil temperature and the indoor coil temperature. You'll notice that the minimum and maximum for cooling is going to be minimum 35 degrees outside, 122 degrees outside for maximum outdoor coil temperature. And that's in the cooling mode. In the heating mode of operation, we're going to get operation all the way down to -5 outside in the heating mode, and then 75 degree for the heating mode outside would be considered maximum for heating if you wanted to run the heat pump portion of it at 75 degrees outside. Likewise, on the indoor coil, you can look at those maximums as far as wet bulb cooling, dry bulb heating, maximum wet bulb cooling, dry bulb heating, and so on. And by the way, this is right out of the installer's guide. So when you take a look at the install information, this little chart right there, I took that right out of the install information. Because we get asked quite a bit, well, how far down will this thing heat to? And it doesn't go into lockout for heating until -5 degrees Fahrenheit. Any questions or comments so far? Is everybody good?
Yep, we're good. Yep.
Okay. Fellows, in this first part of the training, we're going to be discussing the low voltage wiring and the setup of this HMH7 SEER heat pump with a standard AE air handler. Now, the AE air handler features a high efficiency motor, but it's the one that's got 5 speed taps on it that you're actually going to make a speed tap selection on the motor itself. We're going to talk about that low voltage wiring with a simplified block wiring diagram. Now, please remember the AE air handler does not have hard physical screw terminals, but are equipped with pigtail connections. In addition, we're going to be talking about the wiring accessory of this single pole double throw relay in the indoor unit and how it's going to be used for airflow reduction. Because remember, like I said, this is a modulating heat pump outside, but we're going to provide, when it's in the lower stages of modulation, we're going to provide 60 to 65% airflow on the indoor coil when it's in lower modulations or it's in lower capacity. And then we're going to have high airflow at 100% airflow. Now, guys, please remember something real quick. Write this down or please remember, we always want to design our ductwork and set our airflow up for 400 CFM per ton. And so if I got a 2-ton unit sitting outside, I need 800 CFM for 100% airflow inside. If I got a 3-ton unit outside, I need 1200 CFM and so on. So that airflow reduction, we're going to, the way we're going to control that airflow reduction inside is we're going to have a single pole double throw relay on the indoor unit. And we're going to talk about how we're going to use that for airflow reduction. Now, kit number HMH7AK001 is going to be recommended for convenience and supplied parts. Now, what it is, that kit that we're talking about is going to have a biflow filter dryer. It's going to have a relay. It's going to have a relay assembly in there, and then it's going to have some wires to help make it convenient to hook this thing up. Now, the obvious question that comes, well, gee whiz, Joel, what if my contractor wants to use a peanut relay, supply his own little peanut relay and his own biflow dryer and just make up some field wiring? Could he do that? And the answer is absolutely. You could do that, but for convenience, we recommend this HMH7AK001 kit for convenience and supplied parts. Now, please note, if you have the 002 relay kit, you can use it, but it's going to have 2 relays on there. You won't use one of the relays, the RV relay. And so just remember, on the standard ECM motors, you're going to use the 001 kit. On the variable speed products, like a TMV furnace or an AV air handler, a variable speed air handler, or a variable speed furnace, you have to have the 002 kit for the variable speed product, but you could still use it as kind of a universal kit, even on the standard ECM motor, because it just has 2 relays. That's the only difference. The 001 kit has 1 relay. That's an easy way to remember it. 001 is 1 relay. The 002 is a 2 relay kit that you could use. Now, please note also the heat pump thermostat has to have a BO selection for reversing valve operation, because the HMH7, what it does is going to energize the reversing valve in the heating mode of operation. Let me say that one more time. Unlike all of our other Champion products, where we energize the reversing valve in cooling, this product energizes the reversing valve in the heating mode. It's not bad, it's just different. And we'll discuss this thoroughly as well as we start getting into some of our simplified block wiring diagrams here shortly. Everybody squared away? Any questions or comments so far?
Not yet, Joel.
Okay, good. Well, team, let's take a look at, go ahead.
Just a moment, Joel. Did someone have a question?
Everybody good?
Hey, can you hear me, Randy?
Yes.
Hey, what static pressure are you using on when you do the 400 CFM? Are we still doing the standard 0.10?
Yeah, so what you're going to do, if you take a look at the airflow charts on the air handler,
Yeah.
like if you've got like an AE air handler, I think the airflow charts go up to like 0.6. And so what you're going to do is you're going to take your static pressure, your supply static pressure, and your return static pressure, and then you'll add them up, and you'll see what the static pressure is at any given speed tap on that motor. And then you'll adjust the speed taps on the motor to give you the appropriate airflow. So if I've got like a 3-ton air handler sitting inside and a 3-ton unit outside, I'm going to have to set that air handler up that when I have a Y call, a Y call or a compressor call, we're going to drive that indoor unit to 1200 CFM. So the static pressure charts from the factory with the air handler, the install information with the air handler will give you airflow charts that you can set your airflow up based on the speed tap you select and the amount of static pressure you have. Good question. Excellent question. Good. Any other good questions or comments? Everybody good? All right, so as we take a look at the simplified block wiring diagram, you're going to notice on the left-hand side of the screen, you've got a 24-volt heat pump thermostat. Now, remember, it has to be equipped with a B-O selection because we're going to use B for heating mode of operation on the reversing valve. And in this case, we've got an AE air handler, and please remember, it's got pigtails. I'm showing terminal points, but it's just really a pigtail. It's easier just to have a little block for a terminal point. And featuring a 2-stage heat strip, and then we have the HMH7 heat pump setting outside. So what we're going to do, we're going to energize that B in the heating mode of operation. So we're going to take B terminal from the thermostat and take it straight outside. And so pretty straightforward on that. The W2 from the thermostat will go over to W2 terminal or pigtail. If you have a 2-stage heat strip, you'll go W2 to W2. And then W1 will go straight outside and hit the air handler as well. So W1 from the thermostat to W1 first stage heat strip to W outside. Now this has 2 functions. Number 1 is the first stage of auxiliary heat. But also please notice that when the outdoor unit goes into the defrost mode, it's going to energize W1 as well. Because remember guys, when you go into defrost on a heat pump, the outdoor coil the outdoor unit's actually going into air conditioning mode. So we don't want to freeze the homeowner out during defrost. So we bring on some heat strips or auxiliary heat when we go into defrost. So that W outside will feed the first stage of heat strip during defrost as well. Y terminal from the compressor is going to go outside. Now we're going to make some connections on Y in a little bit with some relay, with that relay. But for now, just remember that Y is going to go from Y on the heat pump thermostat to Y outside. Common is going to carry all the way through, 24-volt common, C to C to C. That's pretty straightforward. And R terminal, 24-volt hot, is going to go from the heat pump thermostat to the indoor unit. But now watch this. It does not go outside. We don't require an R terminal outside to power anything up. So unlike some of our other heat pump products that you're maybe used to looking at, we do not carry R 24-volt hot from the thermostat to the indoor unit to the outdoor unit. It does not go outside. And then G terminal is going to be our fan call. That's pretty standard and straightforward. G will be our fan call. And typically what's going to happen if you want to have just continuous fan, that G will go to the lowest speed tap. That's typical. That G will go to the lowest speed tap on that air handler, so that if the homeowner wants to run air filtration, or if they want to just have some continuous air moving, that type of thing, that G call is going to be typically on the lowest speed tap on that ECM motor. Any questions or comments so far before we jump into wiring that relay and talking about that relay function? Everybody good?
Nothing here, Joel.
Okay, that sounds real good. All right, so what we're going to do, we're going to take one side of that relay coil. That one side of that relay coil, it's a 24-volt coil. We're going to take one side of that relay coil and we're going to go up to S1. Now, S1 is going to be an output from the outdoor unit to energize or to de-energize to operate that relay, in other words. So one side of the 24-volt coil goes up to S1 on the outdoor unit. The other side of that coil is going to go to 24-volt common, and that makes perfect sense. It's a 24-volt coil, so anytime we have an output from the outdoor unit on that S1 terminal, it's going to energize that coil and switch that relay. The common terminal, or the common switching point on the relay, is going to go up and hook onto that yellow wire that's going outside, or that Y terminal. So basically, anytime we have a call for compressor operation, we're going to have power to the common switching terminal on the relay itself. Now, on the ECM motor, We'll start talking about wiring the ECM motor. So what we're going to do on the ECM motor, we're going to take the high-speed tap on the ECM motor, and we're going to go up and we're going to tie it onto W1. So anytime we get a W1 auxiliary heat call, or anytime the unit goes into defrost, we're going to drive that inside motor. We're going to drive that ECM motor to high speed. And so this is very typical. I mean, you want to make sure you have plenty of airflow so you don't, overheat the heat strips or anything like that when you go into auxiliary heat. So high speed on the ECM motor goes to W1. Now watch this. On the normally closed contacts on this relay, the normally closed contact on the relay, we're going to go over and we're going to select a speed tap on the motor to provide 100% cooling airflow. So again, if this is a 3-ton unit, this is going to be your 100% cooling airflow speed tap. Now, depending on the size of the air handler you have inside, this might be medium high, or it might be medium. So you'll have to look at your airflow charts that come with the install information with the air handler and select a speed tap on that motor that's going to give you real close to 100% airflow based on 400 CFM per ton. So if I got a 3-ton unit sitting outside, that normally closed contact right there on that relay is going to go over to that ECM motor, and I'm going to select a speed tap to give me 1200 CFM in my 3-ton example. The normally open contact, we're going to go over to the ECM motor, and we're going to select a speed tap that's going to give us about 60%. Now listen, I say about because I realize that, if you're moving speed taps there, and let's say you've got you put it on, let's say medium low, I'm just making this up, or medium, and it gives you a 75% airflow. That's not quite reduced enough. So you might go down to medium low, we'll say. And that gives you 58% airflow. What I'm going to do is I'm going to select the one that's going to get me closest to 60 to 65% of my full cooling airflow. And so the point is you don't want it too low, but at the same time, you want to make sure that that normally open contact on that relay is going to give me an airflow that's going to be about 60% airflow. And when I say about, if it swings down to 55%, that's okay, because that's going to give you a little more humidity control. If it swings up to 65%, that's okay. So we're looking for about 60 to 65% airflow, nominal airflow, and I can swing a few percentage points either way on that low speed cooling tap. Any questions or comments on that?
No, we're good here, Joel.
All right, well, sounds good. All right, so let's go ahead. So we've talked about how we're, the simple block wiring diagram, how we're going to wire the thing up with that relay. But at this time, let's go ahead and take a look at that animation. Let me show you that animation again. So what's going to happen when the outdoor unit modulates down to about 60, 65%, somewhere in there, it's going to generate an S1 signal, which is a 24-volt signal. When it generates that S1 signal, it's going to switch that relay inside, and it's going to reduce the airflow. It's going to command the reduced airflow that you set up on that normally open contact on that relay. So the idea is this: the modulating heat pump outside, the HMH7 outside, is going to make intelligent decisions on when it wants reduced airflow, when it's at reduced capacity outside. And so the net result is this: the unit's going to be running and maintaining humidity, and just giving you a wonderful level of comfort by modulating down outside, but also giving you reduced airflow inside to track that point of modulation outside. Does that make sense to everybody? Why and how we're doing that?
Any questions?
Okay, well, good. Fantastic. Well, fellas, one of the things we want to note too, that regardless of what speed you're on, even if you're commanding S1 reduced airflow, if you get a W1 call on the thermostat, or a W call for defrost on the outdoor unit, what's going to happen? You're going to energize the high-speed tap. And so just please remember that what's going to basically happen is the S1 will be ignored if you get a W1 call for high speed on that ECM motor. And again, please remember the W1 will be present with thermostat auxiliary heat call or during defrost cycle. So that's our basic block wiring diagram for the AE air handler. Is there any questions or comments that we can address before we start jumping into some other products that this unit's matched with? Everybody good?
Yep, everybody's good.
Okay. Let's talk a little bit about it. If we have an ECM furnace, say you have like a TME or a TMY furnace with a high efficiency blower motor, it's going to be very, very similar. There are some considerations we're going to have to think about though. And again, we're going to be using the same relay that we did before, that single pole double throw relay, that 001 kit. The thing we need to remember though, if you're going to be matching this unit with a furnace, we have to have a heat pump thermostat with the BO selection, just like we had before. And we're also going to have a heat pump thermostat that has dual fuel function whenever we use it with the furnace product. So basically, we're going to allow the furnace and the heat pump to be married together, but we're going to have a thermostat that's going to have dual fuel capacity, as well as the BO selection for that B being energized on the reversing valve and the heating mode of operation. So it's very, very straightforward. We'll show you here in just a minute or two the simplified block wiring diagram. Please remember, on the furnace products, we've got hard screw terminals. We actually have screw terminals instead of pigtails on the furnace, where you're going to make up your low voltage wire. So this is going to look very familiar to you because we just did the AE air handler, but just remember, a dual fuel thermostat is going to be necessary on a furnace, and we have hard screw terminals. But just like before, B is going to go outside just like we had before. Looks very, very similar to what we just did, but we're going to walk through each wire again on the furnaces as well. W1 is going to go to W on the single stage furnace and then go on outside. That's for your auxiliary heat call, but also your furnace call. Y is going to go outside just like we had before for our compressor call. C is our 24-volt common. That stays the same. R is 24-volt hot. It just goes to the furnace team. Now remember, that R does not go outside. And G is our fan call, just like we had before. Now you'll notice that on the TME single stage furnace, and this is interesting because some customers aren't aware of this, even though it's a TME, what we call a TME single stage furnace, it actually has 2 stages of cooling capacity. So what we're going to do, we're going to set that motor up for that first stage of airflow. Again, on a Y1 call, the first stage airflow is going to be about 60%, and Y2 will be 100%, just like we had before. So we'll have to change some speed taps maybe on that motor and the control board, but we want to make sure that Y1's about 60%, Y2's 100% airflow. And just like we had before, we're going to take one side of our relay coil and go up to S1 to the outdoor unit. And then the other side of that relay coil, that 24-volt relay coil, will be tied onto common so we can operate that relay. Now on this product here, we're going to take our common up and we're going to grab the yellow wire just like we did before. So that's very similar to what we just did on the air handler. Tie common to the switching contacts over to yellow or to Y terminal for outside. And then the normally closed contact on the relay is going to zip up and tie onto that Y/Y2, that second stage cooling column. Now, please remember, we're going to have to make sure and select a speed tap on Y2 on the furnace to give us 100% cooling airflow. And then the normally open contact on the relay is going to go up, and it's going to grab Y1 on the furnace terminal for that first stage of cooling, that first stage of airflow, I should say, on the indoor unit, once the unit outside modulates back. Kind of watch the animation and we talk a little bit about it. We may ask ourselves, well, what about a TMY furnace? So the exact same thing. So I wanted to stress this. It's the exact same wiring that we just did on the single stage furnace, but you're going to notice something. The TMY furnace is a 2-stage heating and a 2-stage cooling control board. So the TMY is a 2-stage furnace. but it's going to wire exactly like we just did. It's just that we've got 2 heating terminals instead of just 1. So let's go ahead and tie that in. W2 is going to be second stage heat. So W2 from the thermostat to W2 on the furnace, and then W1 will follow through to W/W1 on the furnace, W1 from the heat pump thermostat to W/W1 on the furnace to W outside. Very, very simple, very, very straightforward. Just please remember that the TMY furnace is a 2-stage heating furnace as you take a look at it. Now, as we watch the animation closely here, we're going to see that we're going to switch that relay just like we did before with that S1 output from the outdoor unit. So when the outdoor unit makes an intelligent decision, it says, hey, I'm in reduced compressor capacity. And once it gets down around that 60, 65, 70%, 55, 65%, somewhere in there, it's going to make an intelligent decision. It's going to energize S1, and it's going to command reduced airflow on the indoor unit to that 60 or 65% airflow. So this is really neat. It's a neat piece of equipment. If you've ever put in any of our TH16 product, it's going to be kind of similar in the fact that we're calling for 60, 65% airflow on that first stage or on that first point of airflow, and then the high speed airflow will be 100% based on 400 CFM per ton. So any questions or comments on how we're using the standard ECM motor product, whether an air handler or furnaces, and just that single relay before we talk about variable speed products and a few airflow considerations with the product as we start heading towards the end of the day with that. But any questions or comments so far?
Nope, not right now, Joe.
Okay, well, fantastic. Well, team, all right, at this time, let's go ahead and take a look at an AVC air handler, which is a variable speed air handler, and a variable speed furnace product as well. So again, we're going to be looking at the low voltage wiring diagram with a simplified block wiring diagram. Now, please note something. Some of the terminals that are not going to be used for the HMH7 outdoor function are not going to be covered or discussed today. Some examples are going to be like the Hume terminal. The Hume terminal on the variable speed products is for humidifier operation that has nothing to do with the outdoor unit. The D-Hume terminals, again, has nothing to do with the outdoor unit. The EAC terminals, the electronic air cleaner terminals, has nothing to do with the outdoor unit. So we've eliminated that from our block diagram for the purposes of training today to keep it simple. So we won't be showing those terminals. Now, this is really, really important. The wiring of the accessory relay kit HMH7AK002. This is really important if you're going to be using a variable speed indoor product, either a furnace or an air handler. You have to have the 002 kit because the 002 kit actually has 2 relays on it, and we have to use that for variable speed. You're going to notice that it's going to be designated RV and S1 relay. We'll show you that here in a minute in our block diagram. And again, we're going to recommend this kit for convenience and all the supplied parts, including a bi-flow filter dryer and some conveniently pre-manufactured wires and things to make it easy to hook it up. Please note also the heat pump thermostat, it has to have that BO selection, just like we had before for reversing valve operation. And we want to make sure and select a heat pump that also has dual fuel function if we're going to be hooking it up to a furnace. Let's go ahead and start out with an AVC air handler with a 2-stage heat strip. Now, please remember, air handlers typically are going to have those wire nut connections. And you're going to notice something right away on the variable speed air handler. We've got 2 relays in here. Now, they're actually mounted on a little board, but for ease of simplicity and for talking about it, I like to just kind of show them on the graphic right now as just 2 separate relays. We have one relay that's designated RV relay. We have another designated S1 relay when you take a look at the block diagram. So let's go ahead and talk a little bit about wiring this thing up. So B terminal is going to be for reversing valve operation, just like we had before. Very, very straightforward that way. The W2 is going to be second stage heat. W1 will be first stage auxiliary heat, and we're going to carry that wire outside just like we did before, team, to bring the defrost, bring the heating on during defrost so we don't freeze the homeowner out during defrost. Y terminal is going to go outside, but we are going to be making some connections on the Y terminal inside the air handler. So please remember that we're going to be making some connections on there in a little bit too. So we'll make sure that when you're wiring these things up, you have enough, wires and stuff to where you can make a connection inside the air handler. C terminal goes all the way through that 24-volt common. The R terminal goes strictly to the indoor unit, just like we had before. And then our G terminal is going to be the same we had before. Our G is our 24-volt fan call from the thermostat. Now, we've got two relays to deal with, but let's start with that relay on the right-hand side designated S1 relay. So what we're going to do, as we hook up the coil voltages of these relays, you're going to notice that one side of both relays have to go to common on the relay coils themselves. So as you take a look at those relays, we're going to make sure that one side of those coils on the relays have to go to a 24-volt common. On the right-hand side, the S1 relay, the other side of the relay coil, we're calling it the B terminal. The other side of the relay coil is going to go up to S1 just like we had before. The 24-volt common on the yellow wire going outside for compressor call is going to go to the common terminal of the switching relay. The normally closed contact on the S1 relay will go to Y/Y2 for full speed airflow. The normally open contact on that S1 relay is going to go to Y1. So the S1 relay team, that's going to be your airflow reduction. That's going to be your airflow reduction relay, just like we've had on the other products. Now, where this gets a little bit different now is we have an additional relay called the RV relay on the variable speed product. What we're going to do on the RV relay, the other side of the coil, we're going to go up and we're going to grab the B terminal or the B wire that goes outside the reversing valve. So here's how this works. Whenever we go into the heating mode of operation, we're going to energize the RV relay. And when we energize that relay, it's going to switch its contacts. So just kind of keep that in mind. So when we energize the heat pump for heating mode of operation, we're going to energize the RV relay that we have there with our relay pack. Now watch this, 24-volt common is going to come off that yellow wire again to the switching of the relay, the switching contacts of the relay on the RV relay. The normally closed contact on the RV relay is going to go up to the O terminal. Now, team, here's how this works and here's why this works. And we'll show you a little animation in a second or two here. So the S1 relay is going to be for airflow reduction, just like we had before on the other products. However, on the variable speed product, when the unit is in the cooling mode of operation, the indoor unit, it has to know on a heat pump when it's in cooling mode of operation, and it does that by looking at the O terminal on the indoor unit. So when the unit's in the cooling mode, it has to see the indoor unit now. When the variable speed indoor unit's in the cooling mode, it has to see on a heat pump, it has to see 24 volts on O terminal for some advanced functions like dehumidification and cooling, ramping operation. On the variable speed motor, we're going to ramp that in cooling on delay, for humid environments and stuff like that. So that O terminal drives the variable speed indoor unit for some advanced functions in the cooling mode. And it has to see the O terminal to make that work. So when you look at a variable speed air handler or a variable speed furnace, you're going to notice there's going to be a dip switch or a jumper that says heat pump or AC. Well, once you put that jumper or that dip switch or the jumper to HP for heat pump on a variable speed on the control board, that's a field selection jumper. When you select HP, you automatically tell the indoor unit, hey, it's on a heat pump. And it's going to be looking for the O terminal in the cooling mode. If it doesn't see it, it'll throw a fault. So it's important that we have that RV relay in the cooling mode, energize O terminal anytime we have compressor operation. And then you can visualize and see that when we go to the heating mode and we energize the B terminal For heating mode of operation, we're going to switch that relay and we're going to break that O signal and we're going to tell that indoor unit, now we're in the heating mode of operation because we've lost the O signal. Any questions or comments before I show you a little animation on how all that works? Everybody good? Just wanted to spend a little time with that, though, just to make sure everybody understood how that worked. Tell you what, before we do that, though, let me show you a TMV two-stage furnace. This is something that's so cool. All the wiring that we just did is going to be exactly the same on a two-stage TMV furnace, except the terminals are designated a little bit differently. We're going to have like a W2 and a W/W1. But other than that, everything is exactly the same from our variable speed air handler. So that's kind of cool. Like I said, a couple of the terminals, the heat terminals, are labeled a little bit differently. But other than that, it wires up exactly like we just talked about on the variable speed air handler. So now with all that said, remember that TMV furnace, you have to have a dual fuel capable thermostat if you're going to hook it up to our heat pump. I'll take a good close look at the screen. Let's go ahead and do an animation. Bang. We're going to call for S1, reduced airflow. And so on that variable speed indoor unit, when we get an S1 call from the outdoor unit, we're going to switch that S1 relay for reduced airflow, just like we did before. That's pretty straightforward. And it should be noted on the variable speed products, once you set up your cooling airflow, and let's say we have it set up for 1200 CFM, that high speed airflow is 1200 CFM. As soon as you call for W1 and you drop the W2, excuse me, when you call for Y1 and you drop the Y/Y2, that control board automatically is going to go right to 65% of whatever you have your cooling airflow set up. So it's kind of cool. You don't have to sit here and select any speed taps like we did on the ECM, standard ECM motor product, because these variable speed products have a control board that you can actually select your airflow with some jumpers and so on. And then it automatically, when it sees a Y1 call, it automatically goes to 65% of the cooling airflow that's set up for high-speed airflow. So that's kind of neat. You don't have to try to figure that out or what speed tap it is. It'll automatically do that when it sees a Y1 call. Now look at the animation on the RV relay. Notice that when we energize, let me back up one more time. Notice when we energize the B terminal up above for reversing valve operation, we kind of color coded that a little bit red. When we energize that, we energize the RV relay and we break the 24 volts feeding the O terminal. That's the only reason that RV relay is there, is to break that O signal in the heating mode on the variable speed indoor product. Any questions or comments on the relay function and the logic of the relays on our indoor product with our HMH7 heat pump before we jump into a few airflow considerations to think about as we start kind of heading towards the end of our training session this afternoon? Any questions or comments?
Joe, we don't have.
Okay.
Some of these guys already put this product in.
Okay, so this is probably a review for a lot of you, but that's great. I really appreciate the opportunity to train with you this afternoon. But if there's no questions, let's go ahead and jump into a few airflow considerations. Now, guys, this is really, remember, I'm going to ask that you please remember that on every single install to confirm proper airflow. And this is really important. The HMH7 is a modulating unit, and nominal airflow is going to be critical. We want to make sure we size our ductwork, and we want to set up our airflow adjustments for 400 CFM per ton of total capacity. And so where this becomes really, really critical is if you think about it and just think about the scenario. Let's say, for instance, you had undersized ductwork and you take out, an old 3-ton brand X unit, whatever, and you put one of my brand new HMH7 products in there, and you just have lousy ductwork. And for whatever reason, you got lousy ductwork. And so what happens is the indoor unit is going to be running, and if you have poor airflow on the indoor unit, especially like in the cooling mode of operation, if the indoor coil doesn't have enough airflow on it, what's going to happen is going to start getting colder, right? And so the outdoor unit the outdoor unit's monitoring suction pressure, suction line temperature. It's monitoring liquid line temperature. It's monitoring ambient temperature. It's looking at discharge line temperature. So what it's doing, it's actually plotting its capacity based on temperature conditions and temperatures and pressures in the refrigeration cycle. So if I'm running along and I start icing the indoor coil up, for instance, and the outdoor unit is going to perceive that a colder coil, lower suction pressure, and so on is going to perceive that as a reduction in capacity. And so it's going to start modulating back like it's designed to do if it sees lower capacity in the space based on the refrigeration circuit and pressures and temperatures and so on. And on a hot day, so imagine this, on a hot day, you have lousy ductwork, grandma put pleated filters in there, and you got really bad airflow. The outdoor unit's going to just modulate back like it's supposed to. And on a hot day, you got a 4-ton unit out there that's maybe producing 2 tons of capacity. You get the idea. So it's important that we have a proper airflow on these units if you want them to perform in the full capacity envelope that they're designed for. So please keep that in mind. You know, airflow is always very, very important on any piece of equipment, but when you start getting into modulating units, you know, and it doesn't matter whose brand it is, you know, whether it's our brand or competitor's brand, they all work the same. You have to have good airflow on modulating units because part of their capacity reduction algorithms are based on pressures and temperatures and so on of the refrigeration circuit. So does that make sense to everybody? Is there any questions or comments on that before we have one more little airflow consideration as we head towards the end of our training session today? Everybody good?
You're good.
Okay, one other thing I'd like everybody to please remember too, and this is right out of ACA Manual D. That's kind of the Bible, if you will, in our industry for residential airflow and duct design. So Manual D is our criteria when we design a duct system. We always want to comply with Manual D. As a matter of fact, if you take a duct calculator and you start spinning it and turning it or sliding it and pushing it or whatever kind of duct calculator you've got, that duct calculator that you've got in your hand when you design a duct system is actually based on Manual D. Well, one of the things in Manual D that's really, really important is the recommended velocities of a duct system components. And so it's something we don't think a lot about, but it's something that is important. We want to make sure that we don't exceed maximum recommended velocities in our supply and return components. To give an example here, if we take a look at our main trunk, that's our main trunk going down, you know, from our air handler or furnace. Recommended supply main trunk velocity is 700 feet a minute with a maximum of 900. On the return, we want to see a recommended of about 600 on the main trunk coming back, not to exceed 700 on the return trunk coming back. Our branch runs, our branch ducts, or our branch runs that we take off to each space should have about 600 feet per minute velocity on the supply and about 400 on the return. This is right out of Manual D. We notice that registers and grills and diffusers are all going to be about the same 500 feet a minute velocity on the supply, and about 400 feet a minute velocity on the return is what's recommended, not to exceed those numbers that we show there. And the final one I really, really want to stress, if you've got a filter grill, if you've got a grill that has a filter in it, Manual D recommends you do not have a maximum, or you do not exceed a maximum of 300 feet a minute if you have an actual filter inside the return grill. So we want to make sure that when you're designing a duct system, please don't forget to take a look at the Manual D recommended velocity tables because they'll help you build a duct system that'll be not only the proper size, but they also will be quiet and efficient, and above all, efficient, especially with this HMH7. We want to make sure we nail our velocities from Manual D, and we want to make sure we've got the proper size ductwork when we build our duct system to the tune of 400 CFM per ton, like we talked about, and then we'll have a wonderful operating system. any questions or comments on our little airflow considerations before we start winding down the program with some final questions before we shove off for today? Any final questions or comments? So at this time, everybody, if you want to just unmute your mic or whatever, if you've got any final questions, we'll go ahead and entertain those questions at this time. Randy, you can still take a peek at that chat box, and we'll just give everybody a minute or two to have any questions. And if not, we'll go ahead and conclude our training here shortly.
Sure. Keep in mind, everyone, that the units do not pertain to your application. So if you wanted to order them, I mean, they are available. All you have to do is place your order, and we're good to go. Has anybody, I know a couple of guys on the phone here have installed them already. Do you like the unit? Do you like the performance? You know, what are your customers saying?
Everybody good? Now, I say that we do, everybody's muted, which is fine. Please unmute your mic at this time if you have any final questions. Is everybody good? Well, Randy, I'll tell you what, I'm gonna go ahead and stop the recording, but we'll just keep the line open for a minute or two. I want to thank everybody for training with us today, and I look forward to training with everybody again sometime in the future. Thank you.
Thanks.